All right, let's look at your sample test for Chapter 10. To begin with, we start with 10.1, which is law of signs. For law of signs, remember that you have to have a pair. You have to have two A's, two B's, or two C's. Additionally, when you draw your triangle, it's extremely important that you draw the angles and the sides with the same letters opposite of each other. So angle A opposite side A, angle B opposite side B, angle C opposite side C. We're using the capital letters for the angles and the lowercase letters for the sides. So they tell us two angles of the triangle. If you know two angles of the triangle, you can subtract from 180 to find your third angle. So we could just say 180 minus 100 minus 20, and that would tell us that angle A was 60. So then I want to find little a. I'm going to go back to the given pair, so I'm going to say the sine of angle C equals little c. The sine of angle C is to little c as the sine of angle B is to little b. So sine of C is to C as sine of B is to B, and let's plug in what we know. We know angle C is 100, side C is 40, angle B is 20, and we're trying to find side B. So let's cross multiply, and so we'll get B times the sine of 100 is equal to 40 times the sine of 20. Divide both sides by the sine of 100, and we can throw this whole thing into our calculator. Now you'll notice up here I told you be sure your calculator is in degree mode. I did that on the test as well so that you made sure you weren't doing like half the test in the wrong mode. So we're going to throw this into our calculator all at one time in our graphing calculator, and it tells us that side B is 13.89. Now please remember that once you know two sides of the triangle, you cannot use Pythagorean theorem because this is not a right triangle. So I'm going to go back to the law of signs again, and again I'm going to use my given pieces, my C's, and set them equal to what I'm trying to find this time is little a. So I'll plug in angle C, side C, and angle A, and then that lets me find side C. So let's cross multiply. So A times the sine of 100 is equal to 40 times the sine of 60. Divide both sides by sine 100 and throw this whole thing into your calculator, and you'll have little a, side A, is 35.18. All right, so then for our next one, you'll notice that we have one angle and two sides, and it's not the angle that is between those two sides. So this is a side-side angle triangle. This is the ambiguous case. This is the one that I have to watch out for that can have 0, 1, or 2 solutions. All right, so to begin with, I'm going to use the only pair that I have. So I have the pair of C's, and I have one B value, and so I'm going to have to set the C's equal to the B's. So let's set the C's equal to the B's and plug in angle C, side C, and side B. I'll cross multiply and divide both sides by 6, and I get sine B is equal to this. So I throw this whole thing in my calculator and I get this decimal. Now we are not saying that angle B is 0.368 of 1 degree. The sine of angle B is equal to that value. So we're playing Jeopardy. They're giving us the answer. We're trying to find the question. So we're going to do inverse sine of that value, and it will tell me my angle. Now, only in a side-side angle triangle, we have the ambiguous case where we can get 0, 1, or 2 solutions. At this step right here, if I had gotten inverse sine of a value and I put it into my calculator and I got an error message, that would mean no solution. And that's going to happen when this number is larger than 1 or smaller than -1, because sine can't be larger than 1 or smaller than -1. If, however, I put this into my calculator and it gives me a solution, I'm definitely going to have a solution, but I might have 2 solutions. And the way that I find that is my first solution is going to be what the calculator gives me. My second solution is always going to be 180 minus what the calculator gives me. So those are my 2 possibilities. If I come back up to my triangle, I have 158 degrees right here. If I come back up to my triangle, I could have 158 degrees right here for angle B and 16 degrees right here for angle C and still have room for angle A. So both of those are possibilities. What it would look like if I only had one solution was that maybe angle C was something like 50 degrees, and there wouldn't be room to have a 50-degree angle and a 158-degree angle in the same triangle, and so I wouldn't be able to use that 158. So that's what our three different possibilities look like. If you have a triangle that has two different possibilities for an angle, then we're literally going to find two solutions for every single piece after that. For instance, when I go to find angle A, if I'm going to do 180 minus angle C, which was 16, minus angle B, if angle B is 21.6, then angle A is 142.4. But if angle B was 158.4, then angle A is going to be 5.6. So there'll be two solutions for that as well. All right, now I want to find side A. So again, I'm going to take my original pair, my C's. I'm going to set my C's equal to my A's. And there were two different values for angle A. So first, let's start with 142.4. So again, we'll cross multiply and divide both sides by the sine of 16 to get A by itself. We're going to put this whole thing in our calculator and we get 13.28. So that's one possibility for side A. But also remember that not only was angle A 142.4, but angle A was also 5.6. So we need to find the second solution by using 5.6 for angle A. So again, I've got my C's equal to my A's. I'm going to cross multiply and divide by the sine of 16, and I'll get A is equal to 2.12. So two different solutions for A as well. That only happens with a side-side angle triangle. For my next one, you'll notice that I have two sides and an angle, but it's the angle that is in between those two sides. That's a side angle side triangle. So for a side angle side, you'll notice I don't have a pair of anything. I have one A, one B, and one C. There's no way to do law of sines because I would have to have a pair in order to be able to set them equal. Otherwise, I have two unknowns and I can't solve for two different unknowns at the same time. So I'm going to use law of cosines for this. And for law of cosines, the only angle that I know is angle C. So I'm going to have to use the formula that has angle C in it. It doesn't do me any good to use the formula that finds angle C. I already have that. So that's how I know that I'm going to use the formula to find side C. All right, so let's plug in what was given. A was 12, B was 8, and angle C was 106.3. Since you have your graphing calculator for this test, put this whole thing in your graphing calculator all at one time so it does order of operations for you. Because you have to do this multiplication right here first before you can combine it with the adding and subtracting. So again, if I put this whole thing in my calculator at one time, it'll do order of operations for me. And so that would give me C squared is equal to 261.888. Take the square root of both sides and we'll get side C is 16.18. All right, now I need to go back and I need to find either angle A or angle B. It doesn't make any difference. I found angle A. And so since I'm trying to find the angle, I'm going to use this version of my law of cosines. And so I'm going to plug in what I know. So I know B is 8. I know C is 16.18. So C squared was that 261.888. And then I know that A was 12. And then down here 2 times B times C. Because I want my final answer to be accurate, you can see I'm using the value right here that was not rounded. So even though I rounded 16.18, notice that I'm keeping all the decimal places over here and here, just so that I round my final answer and it's accurate to one decimal place. So I'm going to throw this whole thing into my calculator at one time, and it gives me this value. Again, we're not saying that angle A is 0.7 of 1 degree. That's the answer. We got to find the question, so we're going to play Jeopardy. We're going to do the inverse cosine. So on our calculator, second cosine of that value gives us our angle A. So now, once we know angle A and angle C, we can just say 180 minus angle A minus angle C, and that would give us angle B, and we've solved our triangle. The other type of triangle that we use law of cosines for is a side-side-side triangle. A lot of people like to do one piece with law of cosines and then switch back to law of sines. If you want to do that, it's important that you find the largest angle first if you're going to switch back to law of sines. The way I know what's the largest angle is it's opposite the longest side. So if little side C is 21, then I want to find angle C as my largest angle. So I'm going to use my law of cosines formula to find angle C. And again, I'm going to plug in, I was given A, B, and C, so I'm going to plug those values in and throw that whole thing in my calculator, and I'll get 0.143. And so again, we're not saying that angle C is 0.143 of 1 degree. We're saying that that is the cosine. So we'll do inverse cosine of that value, and it will tell me that angle C is 81.8 degrees. All right, now I could keep going with law of cosines if I want to, or if you like it better, you can switch back to law of sines, because now we have a pair, right? We have a pair of C's, and then we could set that equal to either our A's or our B's. It doesn't matter. I chose to use my B's. So I put in angle C, side C, and side B, and then I'm going to cross multiply or multiply both sides by 15, and I can throw this whole thing into my calculator and find out that sine of angle B is 0.7. So again, angle B is not 0.7 of 1 degrees. That's its sine. So we're going to do inverse sine of that value, and that tells me angle B. There is no ambiguous case with any triangle other than a side-side angle. This was a side-side-side, so there's not the ambiguous case to worry about. All right, and then to find angle A, once I know the other two angles, I can just subtract from 180. And I have found all the missing pieces of my triangle. Now also in 10.1 and 10.2 we looked at two area formulas, the area of a side angle side and the area of a side side side. So for this first one we have a side angle side. And so the easiest way, since there are 3 different formulas on the formula sheet, the easiest way to spot which one to use is to look at your angle. So since we know angle B is 20, then that means that I want to use the formula that has angle B in it, so 1/2 AC sine B. So we'll plug in what we were given. A was 8, C was 15, angle B was 20. Throw that whole thing into our calculator, and we've got the area of that side angle side triangle. If it's a side-side triangle, like we have in number 6, we're going to find the sum of the 3 sides and divide it by 2. So let's go through and say 17 plus 15 plus 21 and divide that by 2, and that gives us S. So that's what's going to go in this formula right here for S, right here for S, right here for S, right here for S, and then A, B, and C are just the sides of my triangle. So here's S, and then S minus the first side, S minus the second side, S minus the third side. Put that whole thing in my calculator and take the square root, and I'll have the area of my side triangle. All right, then in 10.3 and 10.4, we moved on to polar coordinates, and we started off with plotting them. So to plot your polar coordinate, first you're going to start with your angle. So we're going to go to 2 pi over 3. On your formula sheet, you do have the unit circle. So if you look at 2 pi over 3, you can see that's the same thing as 120. If you'd rather use that, that's perfectly fine. So we're going to start at the initial side right here at the polar axis, and we're going to go around 120 degrees. So there's our angle, and then we're going to go out a radius of 3. All right, so you can see like here would be a radius of 1, and then here would be a radius of 2, and then here, if we connect our little hash marks that go through the 3's, that's our radius of 3. So all we want to do is over here at 120 or 2 pi over 3, we want to go out a radius of 3, and that would be point A. All right, for point B, we have 3 negative 2 pi over 3. Now, again, 2 pi over 3 is 120, so that's 3 negative 120. Now, if the negative angle doesn't bother you, all you have to do is just start right here and go down 120 degrees, or go down 2 pi over 3, and then go out a length of 3. So that would be one way to get point B. Remember that also, if you don't like the name of the angle that you're given, you can change it, and we had several different ways to do that. So we could just find the coterminal by adding or subtracting 2 pi. So if we take negative 2 pi over 3 and we add 2 pi, or 6 pi over 3, that would give us 4 pi over 3, which is the same thing as 240. So you could start here at your polar axis and go around 240 and go out a length of 3, and that would be the same thing. That would also give you point B. All right, then for C, we had negative 3 2 pi over 3. So again, 2 pi over 3, if we go around 2 pi over 3 or 120, a positive 3 would go this way. So a negative 3 is going to go the opposite way. So negative 3 would be down here, and that would give us point C. So here's what those final 3 points would look like. Now remember, we had several different ways of coming up for different names for these polar points. And so you can always find the alternate names first and then graph whichever one